This is the question number 9 of GATE 2014 Metallurgical Engineering. The question states that a tensile specimen was deformed at a constant crosshead speed of 6 mm per minute. The strain rate at the start of the testing was 5 into 10 to the power minus 3 second inverse. The initial gauge length of the specimen in millimeter was. Now let us solve this question. This is a tensile specimen which is being pulled by the crosshead at the speed of 6 mm per minute, and the strain rate at the start of the testing is given to us, that is 5 into 10 to the minus 3 second inverse. We have to calculate the initial gauge length of the specimen, that is L0. We have to calculate the initial gauge length L0. So now if after some times, if the length of the gauge length of the samples become L, the gauge length of the sample become L, then the change in length is delta L is equal to L minus L0. So the strain epsilon can be written as change in length, that is L minus L0, divided by initial length, that is delta L by L0, and the strain rate epsilon dot is equal to strain per unit time. So it is delta L by L0 into T. If the change in length delta L, then the crosshead speed can be written as the crosshead speed is equal to change in length divided by time. So now in this case, change in length is delta L and time is T, so V is delta L by T. So now if we substitute delta L by T in this equation, we will get epsilon dot, the strain rate, is equal to V by L0, or L0 is equal to V by epsilon dot. So the crosshead speed is given to us, that is 6 mm per minute. If we convert in the millimeter per second, it will be 6 by 60 millimeter per second, which is equal to 0.1 millimeter per second. So the initial gauge length L0 will be 0.1 millimeter per second divided by 5 into 10 to the power minus 3 second inverse, which will be 20, which is equal to 20 millimeter. So the answer is the initial gauge length of the specimen was 20 millimeter.